In this section, we're going to look at an introduction to statistics and an introduction to some vocabulary centered around data. First of all, we'll ask, what is statistics? And the short answer is it's a branch of mathematics, a study. It's probably one of the newer branches within mathematics. It also employs a lot of areas of science in addition to just plain mathematics. And in fact, it's used for most scientific sort of boundary pushing, right? Where we're discovering new things, testing new ideas. And so it uses lots of areas of science. We use statistics when we are testing hypotheses. It helps us establish links and cause-effect relationships between different real-world variables. When we look at different behaviors and diseases like smoking, respiratory diseases, obesity, heart disease, all of these use statistics to create these links and then possibly to sometimes establish correlation between them. So there's two ways that we look at it. We look at the science of gathering, describing, and analyzing data, and then the actual numerical descriptions of sample data. So just to give you an idea of kind of the process that we're going to be looking at over the course of this quarter, we can look at a study and kind of break down the different areas of statistics that went into creating these results. At the end of 2005, a poll was conducted by ABC News and Washington Post for the purpose of learning the opinions of U.S. adults about the death penalty. So there's an opinion out there. It exists. We want to find ways to figure out what that opinion is. And this is an opinion about a topic, right? A political topic about death penalty. So the first thing that we have to do is to figure out a way to come up with information, right? To come up with data. We have to produce data. And so we go out and we create a representative sample of 1,082 U.S. adults. Each adult was asked whether he or she favored or opposed the death penalty. So that whole part there, producing data, is where we're going to start. We got to look at the different classifications of data. We want to look at how it is that we can reach this quote-unquote representative sample. What makes it representative? How did we find these 1,082 people? Did we just go to each other's friends book list of people and ask those people? How did we find a representative sample that would be representative, quote-unquote, of the population? And then how did we actually reach them? So there's a lot of logistics and things like that that we have to look at when it comes to just producing data. And then collecting the data, making sure that we're not injecting our own bias or fixing the results ahead of time to coincide with what we think or what we're looking for. All right, once we've collected that data, number two, we in the exploratory data analysis stage, the collected data was summarized. It was found that 65% of the sampled adults favored the death penalty for persons convicted of murder. All right, so sounds like there might have been more data collected than what was initially listed. Just kind of said opposed or favored the death penalty. Maybe there were a lot of different levels to those questions that were asked, because here it got a little bit more specific about where and when people favored the death penalty. But regardless, we evaluated it, right? In this particular case, we basically, if we're asked a question, it will kind of be a yes or no or maybe type of answer. And so what we found is 65% of the yeses, in this case, favored the death penalty if it was for somebody convicted of murder. And then the fourth stage would be 3 and 4, probability and inference. Based on the sample result of 65% in favor of the death penalty and our knowledge of probability, it was concluded with 95% confidence that the percentage of those who favor the death penalty in the population is within 3% of what was obtained in the sample. So in other words, that would be between 62% and 68%. The following figure summarizes the example. So based on what we found here in stage 2, we used probability and some tools of inference to conclude with a 95% confidence that somewhere between 62 and 68 of everyone within that stated population was reflected in that sample. So we're using some inference there, and it was based in probability. And we're going to look at those two things as well as we go ahead. So we collected data. We did it in a certain way. We didn't get too in depth there as far as how we did it. Then we did stuff with that data, right? We crunched some numbers. We found some percentages. And then 3 and 4, we used probability and inference to draw conclusions about a larger population outside of even people that we talked to, and made some conclusions about those people. We can see here kind of a picture of this whole process here. We started off with what percent support the death penalty, right? And there was this population we called the U.S. adults, from which we took a small sample of about 1,000 people. And then we looked at that sample, we analyzed it. And the analysis that we did found that 65% were in favor of the death penalty. And so, but that of course only applies to this group that we looked at. But through some special tools that we have, some probability knowledge that we have, we were able to make an inference about the larger population here, where we said that the actual population would be somewhere within is kind of a plus and minus deal, 3% of that 65%, which would put us between 62 and 68%. And that's just kind of a big picture of the process of a statistical study and what types of conclusions we sometimes are looking to make. So let's look at some key vocabulary that some of which we saw in that previous example. And of course, like within mathematics and any other field, we usually have some specific definitions that go with these particular words, where in other contexts they might mean different things. So first word, population. We think of population, you think of, the census, the population of the U.S. or the population of a state. But really when we talk about a population, it's a large or particular group of interest upon which our study is focused. So I said large, but it doesn't necessarily have to be large, but it's usually larger than the sample we collect, which we'll get into here in a little bit. But it's a particular group, and we want to have to define that very specifically. In the example that we had, U.S. adults seemed to be the defining population of interest that we were focused on. So, for example, if an educational group wants to know the percentage of minorities within an urban school district, we think about, the population there. What would be the population that we're focused on? The answer there would be the school district. We are interested in getting information about people within this urban school district. That is our target population. Now, the variable in this case, the thing that's going to differ from individual to individual, and we talk about the individuals here, those can be people, those can be things. In our book, they actually refer to them as cases. I've never heard that term used, but at any rate, you'll see that word, and I like to use the word individual, but cases. It is really, those can be people or those can be things, right? It's the who we're collecting the data from, one by one who they are. Second example, software maker wishes to know the operating system used by a majority of computer users. So here the population would be computer users. And in this case, the individuals in this group, or the cases within this group, would be, the individual computer users. The variable that we're looking at, the thing that's going to vary from people, individual to individual, from case to case, would be the operating system. So don't confuse the population with the variable. That's what a lot of people will do. All right, and if we're collecting information, we're focused on this population, there's something we want to get from that. And so that's what we gather. The data is the information that we gathered from the population. Singular form for data is datum. Just a little, probably will never use that word, but that just a piece of trivia there for you. Census is the gathering of information from every member within a population. And you guys know that just a couple of years ago, we conducted a census. It happened to be within the middle of 2020, which was a worldwide pandemic. So there were issues that they had in trying to gather that data. But the goal was to collect information from every member within the population. So when we gather data and we gather information, we usually will come up with numbers to describe that population. And any number that describes a population is called a population parameter. And typically we use group letters to represent those, or Greek letters to represent those numbers, such as mean. We'll use mu or sigma. These are all different numbers that we're calculating that helps describe things. And we call those numbers parameters. So they are numerical descriptions of a particular population. Most of the time, population parameters are really difficult to determine, mostly because the population is too large for us to actually talk to everyone within that population. And so we end up settling for our estimations for our parameters. And in fact, most of the time, population numbers are too hard to come by. And so we settle with collecting samples instead from those populations. A sample is simply a subset of the population, and we do it because it's easier. It's easier for us to gather information from a sample versus an entire population. And it's usually a pretty good estimate. We have to go into it eyes wide open, knowing that, hey, this is going to be an estimate. It's not going to be the real deal. But it'll get us pretty close to what the real numbers are. And we do a lot of math around that to look at how close are those numbers that we're going to come up with. Sometimes it depends on how we collect the data, and a lot of times we can have an idea of how close a particular number should be. And any numbers that we get from our samples, we call statistics, right? You think statistics applies to just numbers that describe, populations or whatever, but those are actually parameters. And in fact, when we talk about statistics, statistics are numbers that come from samples. So it is important for us to make distinctions between population parameters and sample statistics. Throughout this book, it's critical that we know the difference between them. And basically, the difference between them is their source. Did this number come from numbers that we collected from an entire population, or did they come from a sample of that population? We use different symbols for each. Statistical formulas can change sometimes if it's a sample versus a population. We'll see that with standard deviation. For example, with mean, we use the symbol mu. Mu means population mean, and x bar means sample mean. And we're going to look at that in a couple of sections. So for each scenario, we're going to determine where the sample is and where the population is. In a survey, 359 college students at a University of Jackson were asked if they had tried the October flavor of the month at the campus coffee shop. 83% said they had. All right, so in this case, we have to ask, what is our target population? And in this case, the target population would be the students at the University of Jackson. So we'll put that here, students at UJ. And the sample would be our attempt to get an idea of how the population feels, right? So that would be the 359 college students that we talked to. So samples are always smaller representations of larger groups. And if we were looking at what the variable here was, the variable would be whether they had tried the October flavor of the month. In our second example, a survey of 1,125 households in the U.S. found that 24% subscribed to satellite radio. So what is our population in this case? The population here would be households in the U.S. They did say households, right? So they're not talking about necessarily individuals, but like families in the U.S. And the sample was the 1,125 households that were surveyed. 24% of which subscribe to satellite radio. So there's our variable within the study. When we hear statistics, it's also important for us to know or to discern whether or not what we're being told is a population number, right? A population parameter, or is it a sample number? Are they just describing what people in a smaller group that's meant to represent the population, which would be a statistic. So, for example, here, the average grade on test 1 in Ms. Shirley's statistics class was an 87. Is that a population parameter or a sample statistic? One thing you want to think about is, what is the target population here that's being described? And it appears that the only thing that's really being described here is a very specific population, and that is Miss Shirley's statistics class. And so if we're told that the average grade on test 1 was an 87, we're assuming that she didn't take a sample. That's just what it was. So her target population matched what went into coming up with that number. Right? All of that population was used. And so this would be a population parameter. Populations can be as small as a single class. So that number, 87%, which was an average, was a population parameter number. The second, the average math score for all high school seniors who took the SAT was 519. So is this a population parameter or a sample statistic? It looks like this would be a population parameter again. It's possible for the SAT board to actually know what the average score was for high schoolers. And in fact, that's what it says here, is that all high school seniors were included in this number that they calculated. So the best to our knowledge, this sounds like a population parameter. In a survey of college students, 52% said they plan to attend graduate school. So a lot of times we have to think in terms of, is something realistic? Like, is it realistic for them to have surveyed every college student in the country? And most likely it sounds like this would have been just a survey of college students, not necessarily all college students. So this sounds more realistically to be a sample statistic. So there are two real groups of statistics, and we're starting out with one of them. So let's talk a little bit about the difference between descriptive versus inferential statistics, because they both interrelate with each other, but they're very different, right? When we think of statistics, technically we usually think about the descriptive side. Descriptive statistics includes the gathering, which is a science in and of itself, sorting, organizing, and reporting of various information concerning a sample or a population. These are the cold, hard facts. These are just the numbers that we generate. There's nothing really disputable about them. Generally, as long as the data has been collected appropriately, these are descriptive statistics aren't really disputable unless we did something wrong in the calculation, right? So when we think of descriptive statistics, we tend to think of those statistics that we memorize. If we're a big sports fan, we might want to memorize statistics about our favorite players or our favorite teams. But these are the non-disputable facts. Now, the inferential side, this deals with the interpretation of the information that we've collected. And this is where we take these cold, hard numbers, usually drawn from samples, and we infer something from these numbers about a larger point or a larger population. And so there's some inference here. And it's really our interpretation of what we've collected. And usually we're trying to describe an unknown population parameter based on what we've collected from our sample. We say unknown because populations tend to be large enough that it's very difficult for us to reach everyone. And so we have to be okay with and to kind of settle with making conclusions about the population based only on the numbers we're seeing from our samples. For example, based on a study of 3,123 people, it's estimated the average lifespan of American males is 75.37 years. Now, we didn't get into the details about how they came up with this number, but it was based within sample data. And so we assume that the sample data we collected kind of pointed us into this direction, about which we're talking about the average lifespan of American males. Well, there's more than 3,123 American males. So we're taking this smaller group and we're concluding something about a larger population from that small group. That's inferential statistics. We're going to get to that near the end of the course. So let's look at some examples here. We're going to decide whether these are descriptive or inferential. 82% of the employees at a small local company attended the company Christmas party. This is probably simply descriptive. It's a small enough group that we could probably have actually collected the information, and we're not having to infer anything. We're just crunching numbers. Number two, based on information from a recent survey, social scientists believe that 21% of all married men would admit to having an extramarital affair. In this case, we're talking about 21% of all married men, and this is from a recent survey. Well, didn't this recent survey all married men? Probably not. So they're getting this number from a sample, and they're doing some inference there. So this would be inferential. We're taking it from a sample to a larger population. The average age of entering freshmen at a local university is 20.8 years old, according to the records of the registrar. These are just the facts, ma'am. This is descriptive, and there's nothing that we have to infer. It's according to the records of the registrar, and it's a small enough group, one local university, where we could actually easily get these kind of numbers. The average number of hours vacationers spend in national parks during the summer months is 4.5 hours. Oh, this is probably a big enough population where we're back to some inferentials going on here. We're not going to be able to know the actual time that all vacationers are spending in national parks. So when we collect data, right, we talked about the variables, what's the thing that's going to vary from case to case or individual to individual that we talk to. And there's lots of different types of things that we're going to collect. On some of those, it was simply a yes or no or maybe, right? So when we collect our data, it's literally made up of a bunch of yes, no's, or maybes in a data sheet. Other times we may be taking measurements like what is your height? What is the weight? What is the average, this, that, or the other? So variables can be names. It can be qualities that we're measuring. It can be opinions, but it can also be numerical in nature. And so we can break it down into two different types. One we call categorical, or sometimes it's referred to as qualitative, meaning qualities. And these are like labels or descriptions, right? They tend to be words that reflect qualities about it. Like I said, it tends to be non-numerical, but it can actually involve numbers that are describing non-numerical traits. For example, if we look at the area codes within a city, area codes are numerical values that are really describing geographical locations. And so those would be non-numerical traits. Now, there are numbers that we at times collect that actually have numerical meaning. And these tend to be counts or measurements. We call these quantitative variables. Counts or measurements, how many children are in your household? What are the ages of the children in your household? So we have the counts and then we have measurements. It involves data that's numerical, and that numerical data actually has numerical meaning. And one of the ways you could ask is like, if we do stuff to these numbers, if we do mathematical things like finding averages and stuff like that, do those numbers that we come up with have actual numerical meaning? So can we manipulate them in ways that qualitative or categorical data cannot really be manipulated? We can't really add up hair color, right, which would be a trait or a description. So looking at categorical or qualitative versus quantitative, if we talk about the heights of the members of the basketball team, that would be quantitative because that would be a measurement. Flavors of ice cream at a local parlor, this would be categorical. The jersey numbers of the Seattle Seahawks, well, this would be, I want to say unfortunately, I'm just still mourning the loss of our quarterback, but the jersey numbers, these would be numbers, but those numbers really don't have any numerical meaning. So this would be categorical. The waiting times at a busy intersection, well, that's a measurement, so that's quantitative. And the number of planes landing at SeaTac Airport, well, that's a count. So that count would be quantitative. Now we can actually take our quantitative data and further classify it and distinguish between data that's counts and data that are measurements. So for data that are counts, we call those data discrete data. So discrete data are counting numbers. They tend to be whole, usually because when we're counting, we don't take fractions or decimals. Now, when we actually crunch the numbers, sometimes we get decimals. But if I was actually collecting data and I was asking the number of household pets that we have in a given population, none of those numbers would be, these are the numbers I'm collecting, fractions. We wouldn't have half of a pet, right? Even a small pet is still a whole pet. But when maybe we do some averaging, we find that most households have 1.5 pets. That just means most households have between 1 and 2 pets. But those are numbers that we are crunching from our data. So discrete numbers tend to be whole, and they tend to not take on forms of fractions or decimals, where measurements we call continuous, which is kind of a weird word to use, but we use that word because for measurements, they can always be taken more specifically, or we could always be more precise in the way that we're reporting them. So they can be whole, but they can also be fractions or decimals. And one of the things we can always ask is, hey, can this be more specifically expressed? Could we get more accurate in our measurements? And the answer, if is yes, then it's most likely a continuous number. Most measurements, height, weight, length, or time, can always be more specifically expressed with greater decimal measurement. In fact, if you think about it, most measurements that we make, we can never really truly know what the true number is because it can always be more specifically calculated. So in a discrete versus continuous line, if we were looking at the temperatures in Fahrenheit of various cities throughout Washington, this would be a continuous number. This is a measurement. The number of foreclosures on houses in the Pierce County area, that would be a discrete number because that would be a count. The current mileage on a used car, well, this would be a measurement. Usually we report it in whole numbers, right? But it's still a measurement. And it can be reported to even greater precision if we wanted to, but usually we're just satisfied with the number of miles. The number of planes landing at SeaTac Airport, well, that's discrete. Hopefully there's no fractions in there. The number of peanuts in a jar, assuming they're all whole, again, that would be discrete. And then the weight of that same jar of peanuts, there we have a continuous number. And that concludes this first part of our lesson on data.